Right, let's get started. So first of all, thank you everyone for joining. So a few words about myself. My name is Ruslan Gilfanov. I'm a software engineer. So this is my third year coaching FLL. So 2018 Interorbit season was our rookie season. It was an amazing learning experience. And since that time, we are not looking back. So we're in this for a long run. In 2019, we were fortunate enough to do well on state. So we won first place championship and robust performance and advanced to World Festival, which unfortunately got canceled. And this is also my first year mentoring FTC, which I can say this is a very, very steep learning curve. So we'll see how that goes. So about this talk, I prepared a few slides that they're not going to cover everything, of course, but I think it will establish some good framework and start our conversation. And then we should have plenty of time for questions and answers and going deeper into any of the topics that we want. So what this talk is about. So first of all, what I'm not going to talk about. I'm not going to talk about things like connecting robots over Bluetooth, downloading software, or programming algorithms such as line followers, etc. So all of these topics, they are very well covered on the internet. There are probably hundreds of YouTube videos covering all of these things. Except we're going to spend some time talking about Spike Prime versus EV3 comparison, because this is kind of big deal. So EV3 has been around for 7 years, and Spike Prime is the first iteration of competitive robotics that came out since that time. But the main focus of the presentation is I would like to share what we learned from our experience. Wanted to talk about some lesser known things, observations, and tips and tricks. So let's talk about Spike Prime and EV3. So first of all, I wanted to get it out of the way. Both are very viable options, allowing you to compete at any level, ranging from absolute beginners and to very advanced level of competition. So the robotics set selection only affects brick, motors, and sensors. Everything else, which is general Lego, can be mixed and matched. So you can take parts from Spike Prime set, use it on EV3, and vice versa. So programming options are very similar, but not identical, and we'll go deeper into that. What you already have is definitely a huge factor. So it's Spike Prime's first year, and EV3 has been around for 7 years. So unless this is your very first season and you don't have haven't purchased anything, chances are you already have an EV3 set and probably more than one. So let's do a brief comparison. Spike Prime pros, first is its size. So it's smaller, it's lighter, and comes with a rechargeable battery. Motors and sensors, the form factor is different. So many people think that the shape is better and it's easier to build with. Next one, it has built-in gyro versus non-functional gyro. If you had any experience trying to make gyro work on EV3, you know that, I don't know how many hours of people around the world spent trying to make it work, and no one could. Basically, at random moments of time, it will just start this thing called drift. Just start counting, increasing angle over time, which will completely ruin your program. Spike Prime set comes with an interesting set of parts. They have large frames. They have these 3x3 pieces called biscuits, which are very helpful with building. They have these banana gears and a few other things. And the boot uptime and Bluetooth connectivity are significantly improved. So these are all good things, but not everything is so great. So one of the cons is about ports. So it comes with 6 input-output ports compared to 4 input and 4 output ports on EV3. And that could have been an advantage, but it's not, because FLL season rules, they specifically limit you to 4 motors. If not for that rule, you could have used 6 motors. And that can be an advantage, because not always you need to use many sensors. Another con is buttons and screen. So the Spike Prime brick looks very nice, but for competition use, if you look at the dot matrix they have and just 2 buttons, that may create some additional difficulties for selecting missions during your matches or outputting some additional information on the screen. And then there are also non-detachable cables of single length, which may present some problems with building. But robotic set is not the only thing you can use, and I would actually encourage everyone to explore other parts, other sources of parts. So first of all, you can mix and match sets, and you can use any official Lego parts with a rare exception. I think the only exception are pullback motors. But then I encourage everyone to just get inspired by and borrow parts from Lego sets that you may have at home. In addition to that, there are several online resources which are great sources of parts. So the first one is Bricklink. If you haven't used it, I highly recommend it. So it's basically a marketplace of Lego, probably the world's largest marketplace, where you can pretty much buy any parts, and that doesn't include the current parts. You can buy parts that come from discontinued sets, from sets that are no longer in production. So you can get all of the regular stuff, gears, axles, beams, pegs. And then it's probably one of the best sources of wheels, because wheel choice is going to be one of the first decisions you'll have to make as you build your robot, and they have hundreds and hundreds of wheels. Another thing I would recommend is just use your imagination or browse around. You can find and use odd or unique parts, which can give you some advantage. For example, if you need to use this bucket that's on the right, you can do that. Or on the right, in the top corner, there is this like a linear actuator with a spring inside. So lots of very interesting parts that you can find and use in your robots. And then there is always eBay and Amazon. Many people sell a lot of stuff on eBay and Amazon. And if you are looking for a particular part, then chances are you can find it there. Let's talk about programming. So in the past couple of years, options have expanded dramatically. So if you look at what is available as of September 2020, so this is what we have. And I wanted to note that this area is very dynamic. So what I'm saying here may change next month. So please keep an eye on that, because as I said recently, I noticed a lot of development in these areas and improvements in available software, which is great to see. So both platforms, they have Scratch available. That's the most welcome recent addition. So it's a very popular block-based programming language. Many kids are already familiar with that, and now you can program robots with it. So Scratch comes standard with official Lego software that you can download from their website. And then there is Python. It's very interesting because up until last year, you were not able to use anything other than official Lego provided block-based languages. And Python is a professional text-based language, which is a very good option, I would say. Both platforms support that. There are some interesting differences. So for example, on EV3, the big advantage is that there is a very nice Visual Studio Code extension, which makes programming and uploading to your robot a much easier process. For Spike Prime, they actually have built-in Python support within the Spike app. So this is probably the easiest way to get introduced to Python, because it doesn't require any special setup at all. And then there is the LabVIEW software, which was a standard for many, many years. If you used it, you know that it feels pretty dated, just the UI and the speed and the interface, but it does have some advantages still. For example, it allows you to have multiple tabs, multiple files. So if your program is large, you can split it up into separate sections. And then there are some lesser known options like make code, which allows you to use blocks and also program in JavaScript. So as we now have these two distinct options, using blocks or visual programming or using text, many people are probably wondering what should be a decision framework around that, and what should we use given the choice. And probably most people think that visual programming, block-based programming is more kids-friendly and allows an easier entry and not as steep learning curve compared to professional text-based languages. And this is certainly true, but from my experience, it's not that obvious. So I tried to express my thoughts in that diagram. So on the x-axis, you have the program complexity going from very simple to complex. And then on the y-axis, I have ease of use. So as you can see on the left, the entry level for block-based programming is very low. You can just start programming, just download software and start programming. And elementary school students can make the robot move in a matter of minutes. So the entry point for text-based languages like Python is considerably higher. But at the same time, as the complexity of your program evolves and increases, as you start using more advanced algorithms like line followers, the picture changes actually quite dramatically. So in my own opinion, there is a certain point of complexity at which using blocks can actually become much harder than use the text-based language. So as an example, so this is what a PID line follower algorithm looks like implemented in blocks. So even being an experienced programmer, I can tell you that I have a really hard time understanding what's going on. So all these blocks and connection lines, it's really hard. So I don't have a comparison picture for what that would look like in a text-based programming language, but it's basically 10, 12 lines of code. It's very easy to understand, it's very well structured. So in my experience, I can claim, and we use Python. That was our first year of using Python last year, and we had a team made of 6th and 7th graders. I can tell that they are perfectly capable of learning the basics of it and use it to their advantage. So I highly encourage you to explore this option, especially if you have older team members. Now, another big advantage that text-based programming languages give you are user source control, right? Because it's a long season, it is multiple months, you have multiple team members, and especially with COVID, amount of remote work may increase. So if you did FLL in the past, you know that there are some challenges associated with just keeping track of changes and sharing files. You're probably email files or sharing files on Google Drive all the time, or just bringing them on a flash drive. And it's very easy to make some changes and lose track of that. So if you never work with source control, in basic terms, it's a system that stores your code on a remote server, tracks version history, and allows multiple people to collaborate on the same code base. There are plenty of free tools available. So GitHub or Bitbucket can be your platform of choice for actually storing your code in the cloud. And then most programming environments have built-in support for source control. Source3 is another free tool that I highly recommend that can help visualize your history of changes. And then it's a professional tool. It's used by programmers all around the world, and it's just a great life skill if you are planning to be an engineer, not necessarily a programmer. That's just very great skill to learn for the kids. And you don't have to be hardcore. Git usage, source control usage can be pretty sophisticated, but a basic set of operations will get you pretty far and you'll start getting benefits. And then if you plan to continue and graduate and continue with FTC and FRC, that's pretty much a must. You will not be able to survive without that. So once again, highly recommend giving text languages a try and giving source control a try. So let's talk about build approach. With FLL, you know that every year you need to solve many missions. It can be as many as 15 missions. And you have limited time to 30, and you are only allowed to use one smart brick. All of that combined inevitably leads to you needing some sort of base robot and a set of attachments combination in order to resolve more than just one or two missions. So let's talk about robot design, base robot design. There are many designs, and if you come to competition with 50 teams, chances are you'll see 50 different designs. So this is a really great thing about this. So, but there are a few components which are pretty typical. So the first one is drivetrain. It's typically two motors and two wheels. Most of the time, some teams, they use tank treads, which can be advantageous in some situations. And I know some teams were able to use that quite successfully. Then you will typically need a couple of casters, which are like can be passive wheels, free spin wheels, or caster balls, or just Lego pieces. Then you will typically have some sensors, which are most of the time it's for navigation and line operations. So you can have one or two or even three color sensors on the bottom of your robot to help with navigation. And then you need to come up with some interface for driving motorized attachments. So it's very typical to have two motors with some sort of gear that will allow you to transfer power to your motorized attachments. So building a base robot is a great pre-season activity. So this advice is a little late because the season has already started, but there is quite a bit of downtime between seasons. So next season, I encourage everyone to just, if you want to keep working, keep your skills sharp, you can work on that. And when the season starts, have a robot or even multiple designs ready. But as soon as the challenge is released, you need to review the base robot that you've got and see if you need to make any challenge-specific modifications based on the set of missions you have. It may involve changing the wheels, changing clearance, changing sensor configuration. So that was a pretty typical approach to building base robots. But then, of course, there are some lesser known approaches which may be advantageous in some situations. For example, one good alternative is you can build the base robot with some built-in general purpose mechanism, such as elevator. So if you think that this mechanism can be helpful with many missions, then you can just build it into your base robot. Attachment design. So there are a lot of variability in how you can do that. So the first consideration, you can attach attachments with pegs, or you can build so-called pinless attachments. So pegs, you can do that. You need to be careful because you will need to put and remove attachments, and things will be flying around. Just pay attention to structural integrity. Pinless attachment is an interesting approach. So basically, you design an exoskeleton which you drop on your base robot, and it will just use gravity to stay in place. So that will allow for very effortless and easy attachment swapping. And that should be one of the key design focuses for the team, to make sure that it's very easy to swap attachments and that they don't fall apart as you do that. Next thing, you can and you will be swapping whole attachments, but There is also a possibility to do some minor rebuild, because the attachment that you used for the previous mission may very well work for the next mission if you just add or remove a small part, like a single beam. So you should consider that. Weight distribution, in our experience, that's one of the biggest things and challenges, because as you design the base robot, so we'll have 2 drive wheels and there will be some weight, right? So what are the sources of weight? So the brick and the battery themselves are pretty heavy, and then your attachment can be lightweight, it can be very heavy, and it can have most of its weight in the back or on the front, and that will change the weight distribution, and it will change the pressure of the wheels and traction on that surface, and that can change the driving dynamics quite a bit. And then the last factor is inspection area fit. So that was a new rule last year, and it came back this year. So when we first saw this rule last year, we were a bit scared. We thought that, yeah, it's going to be really hard to fit into the inspection area, but in the end, somehow it turned out that it's not that big of a problem, but still you need to pay attention to that and kind of try to keep your base robot and your attachments compact so that you can get additional bonus here. A couple of advices from experience that we found to be working pretty well, and so that worked for us in the past couple of years, is about splitting up work between students, because it can be really challenging. So the split that we found working exceptionally well is the following. You can have a student or a group of students work on a base robot design. Just build the base robot, maybe prototype several different designs, and just do that. Then you can have another kid or group of kids work on programming of common functions. So common functions, they can be responsible for navigation, so things like drive straight or point turn. And there is a variety of line algorithms, follow line, stop at line, square on line. And this is a very useful set of functionality that will then can be used for programming missions and attachments. And that all of that can be programmed independently. And then building and programming particular attachments, in our experience, it's pretty hard to split, because as you do that, there will be this constant test and modify feedback loop. So you have a version of your attachment, you have some programming, you run it, you see how it performs, you notice some changes, and then you'll probably need to make some build changes as well as software changes. And if one person or a group of students are doing that, it's just going to be much more efficient. And finally, some advice on remote work. So it's going to be a particularly challenging season. And if students can do some of the work outside of your regular meeting place, that can be an advantage. So the first most simple way to enable that is you can detach mission models and take them home. Or you can build copies of the mission models depending on their complexity. And then you can continue building your mechanism attachments to solve these missions. If you define an attachment interface that can enable independent work, for example, if your base robot has these dimensions and features 2 gears that will transfer power to your attachments, and this is standardized, then you don't even need to have another base robot. You can work on that mechanism just knowing these dimensions. So if you have more than one robotics kit, then you can consider building multiple base robot replicas. So that can allow independent programming of the basic navigational functions that I mentioned on the previous slide. And then source control will just make it 10x easier, like programming and communication between students. And then the last one, which is probably the most resource consuming, but pretty doable, is you can consider building some extra competition tables. There are DIY instructions on the web, and you can buy parts pretty cheap at Home Depot and build another table. You can obtain some extra field kits, and depending of how you progress throughout the season, very often after a certain round, after round of qualifiers, many teams will be selling their kits. So you can definitely consider setting up more than one table and field kit environment. So this is all I had for today. I'm happy to take any questions. We have plenty of time, so we can happy to go deeper into any of the topics or answer any of the questions you may have. Thank you.
Could I get a link to the extension you mentioned for Visual Studio Code?
Oh yes, you can actually find it from the Visual Studio itself. So if you just download it, on the left side, you will see a button called Extensions. So you click it, and it's like an app store. You will start typing EV3, and it will just pop up right away.
Okay, it's like a library of functions for the motors and stuff?
It's not a library, it's an interface that will allow you to upload your code to your robot remotely. So it's really easy. It pretty much becomes like a Lego native Scratch environment. And then the only other thing you'll need to do is create an SD card image with Python. So Lego website has all of the instructions, so it's really simple. I can send you links to all of that. So you flash micro SD card, and then you insert it into the port on the EV3 brick, and then it will convert itself into Python-enabled brick. And then if you need to go back to regular firmware, you just remove the SD card, and it will go back to normal. So
okay,
really
that's
simple.
easy.
Yeah.
There's that.
And so one thing to pay attention to, let me go back to that. On the left side, there are actually a couple of options for Python. So the first one is Lego's official distribution, which they have on their website. It has a very nice documentation. It's very user-friendly. And that's what we started with last year. But halfway through the season, we noticed some like fatal bugs in that. So some motors will just start spinning randomly at a random moment of time during execution, and which made it unusable for us. Then we showed the web, and then there is a much more mature library called EV3 Dev2. In fact, Lego's version is based on top of that library. So it's supported by fans of EV3, not even related to FLL or competition necessarily, but it's been around for a very long time. It's been actively developed. It's a little less user-friendly just because it offers more possibilities. It's more powerful, but you can still use it, and the same Visual Studio Code extension works perfectly with it, and that's what we ended up using last year. But this year I checked, and the Lego's version, it's actually version 2. Last year it was version 1. So I'm wondering if they actually fixed that. We haven't had a chance to verify that, so maybe it's no longer an issue.
Have you had any experience with the Spike Prime? I mean, is there any reason to switch over to that from EV3?
So if you don't have any other reasons to stay with EV3, like if you are considering which set to buy, I would recommend to go with Prime, yes.
Huh.
So in my opinion, it has enough advantages over EV3. But like I said, both sets are perfectly viable options and will allow you to compete at any level. Yeah, we've had some experience with Spike Prime already, so I can like talk more about any of the areas, but that is a short list of major pros and cons that I see.
Screens and buttons.
Maybe the weirdest one is that I didn't realize the cables, are they attached to the motors and sensors?
Oh, yeah, they are.
Built-in gyro.
So if you damage the cable, you will either need to do some soldering or replace the whole unit.
Amy, I think you might have come in after Ruslan had gone through this slide. So if you have some other questions about that, go ahead and ask.
Thank you. I feel bad that I was late, but my husband had a meeting and I had to read to our daughter. I just don't know yet. I bought a Spike Prime. Our school has, I don't know, 30 sets of EV3s, 30
yeah.
EV3 sets, and we're in deep with EV3, and that's fine. But I did buy one set just to play around with this year if we ever get kids back in the classroom and we can do this. So I was curious, you know, what you thought was superior for an FLL team, but it sounds like Prime.
Yeah, so let me just go over this again. So the first one is size. So it's noticeably smaller and lighter, just the brick itself. And then the motors and sensors, they have a better shape. So the motors are pretty much flat, and the way the axle, the shaft output is positioned, it just makes it possible to build more compact robots. So it's easier to build with. And then built-in gyro is a big thing. So you no longer need to use gyro as a sensor, which you attach with a cable. It's built inside the brick, and it actually works. Yeah, EV3 gyro sensor is a pain. It's like a lottery. You can use it, and it can be helpful, but you'll never know if it will ruin your run.
I'm so glad to hear you say that, because I've never had a lot of success with it. I've also struggled a lot, and this is embarrassing, but my kids have always struggled just to program it to follow a black line. Like it weaves in and out. It doesn't do very well. What is the best way to do that? Is it to use the color sensor, or when you're having it just go straight off and stop, do you just tell it to go for a distance?
So you definitely use color sensor for that. Probably the best single advice I can give about making all sorts of line algorithms work is shielding. So the ambient light you have in your room, it will impact the reading big time. So try to place your sensor as close to the ground as possible, and try to build some shield around it.
Thank you so much.
And before you even start programming, just do a basic test. So place your robot with the sensor on top of white part of the line and check the reading. You can just check the raw reading of the sensor, and it should be close to 100 or 96. Okay. And if you place on all black, it should be close to 0. So single-digit numbers.
Thank you.
Yeah, and Spike Prime also has a much more compact color sensor. And other than the base set, there is also an expansion set, which will give you a second light sensor and I believe a second motor. I don't exactly remember the exact split between parts, but if you get both of these sets, you will have everything you need to build a competition robot. Now, one warning about wheels. So wheels, so Spike Prime comes with really nice looking wheels, right? That's probably the first thing everyone noticed. But in our experience, they're actually not very good for competition use, because the surface contact area is pretty small, and they just slip.
Huh. And I also missed your, but I know you just summarized it, but the Scratch versus Python, because I've operated with Macs, and so we've been using, is it for PCs too, that they're not going to support the old Mindstorms, or is it just for Macs they're not supporting the old Mindstorms?
I don't know about the official policy for the support of the LabVIEW software, but I know that both are supported on both platforms. The new software works on both Mac and PC, so we verified that.
Yeah, I know the new one does, the Scratch-based one. And then it sounded like you didn't like the Lego, the Python option on the Lego site. And why was that?
Python option on the Scratch, on the Spike Prime side?
For EV3, but
Yes.
on the site, I know it said you can download something to a card and you put that in the EV3.
Yes.
And then there was I thought there was a platform you could use to program in Python.
Yes. So no problems with that. That's what we used last year, and it worked well. So the only problem I mentioned is a very weird, hard to reproduce bug that we noticed sometimes happens with the Legos version, but that was last year with version 1 of the software, and maybe they fixed that.
Okay. Great. Thank you so much.
Go ahead.
Oh, I'm having my kids learn Python and CodeHS while we're doing distance learning. And it would be really lovely to transition that to.
Oh, absolutely. And it's a professional language. They will be very well equipped later in their life and career.
Okay.
So this is my email address at the end.
Okay.
Ruslan@raptors.com. So send me an email. I can send you all of the links to resources, or if you have any questions or trouble setting this up, I'm happy to help.
Thank you so much.
Bless you.
Oh, I'm so sorry.
Ruslan, I'll let you decide, when there's no more questions or you feel like everything is all wrapped up, that is totally fine to say that we are at the end of our session, and they can always reach out to you with more questions. Anybody, please feel free to jump in if there are other things that you want to ask at this point.
Yeah, so we have time. I'm happy to go deeper into any of the topics.
Can I ask the file structure then? If you have multiple people making multiple Python files, I have a lot more experience in other languages, so I'm not sure how you would do multiple files in Python. Is that super easy?
Yeah, that's super easy. So that will work if you use Visual Studio Code with extension. So the Python version, Python implementation that comes built in the Spike app, it doesn't support proper file management. But with VS Code, you can have any folder and file structure, but you will actually not need much. So the file structure that we ended up with would be One file will contain a library of all common functions, like for line following and driving and turning. Then we'll have one main file, which will contain the entry point for the program, which will contain loop allowing you to select which mission to run. And then each mission will be in its own file. And then the main file will just import all of the other files.
And then do you have like include lines? So
Yes, you do.
okay.
So we'll use a number of imports for EV3 functions and classes to control your modules and sensors. And then you will import your own files if you use that.
Thanks.
Mm-hmm.
I feel like I would have so many questions more if my kids were in the classroom with me actually doing this. I'm sorry, I feel like this is an underutilized resource, but thank you for your email.
Mm-hmm. Yeah, so just feel free to email me any questions.
Catherine, what are you finding with teams? Like how many teams are practicing in person, and what are you seeing with registrations for events? Are there events?
Thanks for asking. Registration for teams is understandably slower than it usually is, but that's totally fine. Everybody's still getting their feet under them and trying to figure out what the landscape is right now for their schools, their families, their teams, whatever the situation is. And so you may have received the emails lately that have talked about first extending their season. Therefore, Colorado First has been able to announce that we'll extend our season. So there's not really going to be a cutoff on registration of teams, at least at this point. We're just going to let things happen as they can for teams. And as far as events go, hopefully you've been reading some of that in the communications too, that our event season has been pushed out. We do not have specific dates yet because, again, we're trying to see how all the pieces fit and what is our best options for the kids, for the teams. We're hoping that if we push them out far enough into the spring, maybe there's some chance of us having some of those in-person but modified events so that they can be safe, good experiences for the kids. But we will have remote options, regardless for anybody that can't or doesn't want to come in person, or if we're still in the same situation we are now, where it's just better to be remote. So what we've communicated so far for Colorado is that for First Lego League Challenge, we're anticipating that the state competition will be in April. And if we have enough teams register where we would need qualifying tournaments prior to that state tournament, those would not happen before February. So we'd be scheduling those in February and March, hopefully around spring breaks, if they needed to be in March. And so we will kind of be updating you as much as we can, as often as we can. Did that answer your questions, Amy, or were there more specifics in there I needed to hit on?
No, not at all. I wasn't looking for specifics. The communication's been really clear. I was just wondering how your sense of everything was as a director.
Right. I think really the teams that I've talked to, the ones that have registered and the ones that are still hoping to register, are very positive. The kids are so excited to be able to be doing something and be able to have this extracurricular or within the classroom if teachers are able to do that. I know Kelly was talking about that a little bit earlier. They're just so excited to be able to get together as their teams and to work on the challenges. So the people I've talked to have been very positive, and that's really exciting and affirming for us too. We're excited as well.
Great, thank you.
Yep, you bet. Anybody else have anything that they wanted to ask about or add in? Okay, if not, Ruslan, I did get a couple of emails while you were doing your presentation. We had somebody have a root canal at the last minute and a couple of other things going on. So they are eagerly awaiting the recording when we're all done tonight. So very much appreciated for all the work that you put into this. And thank you, Kelly and Ben and Amy for joining in with us live tonight. We really appreciate it.
Okay. Thank you, everyone.
Thanks.
Thank you.
Thank you so much. Thank you very much.
So Kathleen, can we get the recording somewhere after
Yes,
this?
I will send you a link to the recording. Yep.
Okay.
So you will
Yeah,
have it.
thank you.
We're also going to post it on the website eventually, but you guys will get first click.
Sure. Thanks, Mr. Ruslan. That's very helpful.
Thank you. Yeah, and please feel free to email me with any questions. I'll be happy to answer.
Thank you.
Wonderful. I think, Ruslan, you'll need to stop the recording and end the session because I think I made you the host.
All right. Thanks again, everyone. Bye-bye.
All right. Thanks so much.